this video, we're going to review the procedure for writing formulas for ionic compounds. The first thing we need to know when we're looking at how to do this is the charges of different ions. So when you're looking at the periodic table, there are some general rules that you should follow. The first is that different columns of the periodic table have different standard charges. So if we're looking at this column, everything in this column has a +1 charge, except for hydrogen, because it's special. It can either have +1 or -1, depending on how it's bonded. And the nice thing is on your periodic table is it does actually say that, but there's some that you might find that don't. Okay, this next column, everything has a +2 charge, and here everything has a +3 charge. On the other side, there's a similar trend, except for the noble gases have a 0 charge. These have a -1, -2, and -3. So it's important for us to be able to tell what the charge of something is going to be, and so it's helpful to think about those trends, especially since you'll notice these nonmetals, they don't say what those charges are going to be. So we may have to remember what the common charges of these are so that we know what charges to assign for them. Anything else in the middle will also say which charge it has. If we don't have any more information and something has 2 possible charges, we're always going to assume that we want to use the first one. Okay? So, how do we write the formula for something? So if we have aluminum oxide, we're going to need to figure out what the charge of aluminum is and the charge of oxygen. So we need to find aluminum on the periodic table. There it is. It has a +3 charge. We also need to find oxygen, and it is 0, 1, 2. It has a -2 charge. So we're going to write the charge of each, and ultimately, when we're writing the formula for our compound, we're going to need those 2 charges to balance out. So the net charge for the compound is 0. So if you think about it, you would need 2 aluminum ions to balance the charge of 3 oxygen ions. Now, a really common way that students do this is by using the cross and drop method. So you can take the 3 from the aluminum and put it down beside the oxygen, and the 2 from the oxygen, put it down beside the aluminum, and then you get Al2O3. So that's where that comes from. Now, the only thing you need to be careful of is if you end up with something like this one here with Mg2O2, if you have 2 numbers that can cancel out, then you would take it to the lowest number possible. So this actually ends up being MgO. All right, so let's look at one example on the next page. All right, so we're going to take a look at copper 2 oxide. Now, the nice thing is that we're told the charge that we want to use in the bracket here, because copper does have 2 possible charges. If it didn't have the 2, it's supposed to, because if there's 2 possible, you do need to specify which. But if it didn't say, then we'd have to assume it was the 2. All right, so copper 2 oxide. So our metal ion is copper 2 plus, and our oxygen is O2 minus. So we know that because of the common charge for oxygen, and we know the copper is +2 because of the 2 in the bracket there. So when we write our chemical formula, we get CuO, and then we have a 2 beside each if we're using the cross and drop method. Now, if they both have 2's, then we know that we can put that in lowest terms, so we get CUO.